Hello everybody, and today I'm going to present you the solution to problem H, Med City, that was given at the Codeforces Round 898 Division 4. This problem, even though it was a D4 problem, it was actually a rather decent problem to try even for someone who is more experienced like I am. And basically we were given a graph that has n vertices and n edges, so basically kind of a functional graph, even though it's not exactly a functional graph, as from a vertex we can go to multiple other vertices from one step, but it still has many of the properties functional graphs have. And basically we have two friends that started buildings A and B, and the first friend wants to catch the second friend, but the second friend knows every time where the next friend is going to head to next, so he has this advantage here. And basically we want to find out if the second friend can escape indefinitely. So in order to go by approaching this problem, we can observe in the samples that if we have a cycle, so if the second friend is in a cycle, he already wins because he knows where his friend will go to next, and he can just go the opposite direction. And this actually gives us a very important insight on dealing with the problem. Now another obvious step to see is that if there is a town such that the first friend will arrive before the second friend does, then the second friend can't go there. And this also goes for towns where they arrive at the same time, as basically the second friend knows that the first friend is waiting for him there, so he can't really go there if that happens. So basically if we have a graph, and let's say we have this graph, and we also have maybe some other vertices. Basically the main point is that we want to make sure that when let's say if the first friend starts here and the second friend starts here, we can start by marking out the vertices where B can never reach. And this can be done by computing the shortest path from A to everything else, as well as from B to everything else. And this can be done with a BFS, as every vertex, every edge has the same cost. So basically these vertices can't ever be reached by B before A arrives there. And B basically only has left these three vertices. And the main issue with this is that, as you can see, A can just arrive here and it will block away B from every path of escaping. So basically, when can B succeed? Actually, it turns out that B can succeed in a situation where he can reach a cycle in time. And this happens if B is close enough to a cycle. Because now in this case, if B would be here, let's say a B2, then he can reach this square here. And no matter where A goes, if he's here or is here, he already knows where A is going to next. And he can just use the strategy I was talking about earlier. So what do we do now? Basically, we need to find out the vertices such that B reaches there before A, and we need to find also the vertices that are part of a cycle. And given the special form of the graph, the algorithm I use to find the vertices that are part of the cycle is to just cut off the leaves, as we know that this kind of a graph with n vertices and n edges is just a few cycles and some tree-like structure. And when I cut off the leaves, I just start with the vertices of degree 1, and I keep doing this over and over until I'm done with cutting everything. So after these two, I would cut off this one, as it would have a degree of 1. And after we are done with cutting off these vertices, I just check the conditions described in the statement, and then I just made sure to, here I computed with some BFSs the distances from A and B to everything else. Here I computed the degrees of the vertices and I cut off the leaves, and then I just checked the distances if they work or not. As you can see here, the solution was implemented rather fast, and it actually took me less time to get this done than it took me for problem G. So this was interesting in a way. But again, a very good graph problem in my opinion, especially for someone who has a bit of experience with graphs but not let's say too much experience. And again, a good challenging problem given the level of diff 4. And overall I have to say that this round was very good from the perspective of someone who took it. And yeah, this was the solution video for problem H. And if you found it interesting and if you enjoyed my explanation, please like, share and subscribe to the channel. It helps me a lot. And you can also check the links in the description for more content as well as other ways to interact with me. Until the next time, good luck with practicing, stay safe and have a great day.